Afternoon, everybody. We're going to do another combination circuit. On the left hand side you can see my rules for this. Series circuit rules, parallel circuit rules, Ohm's law, Watt's law. If you don't quite remember how to use those, you can look back in this series of videos and there will be some that can help you. This circuit is kind of interesting. It's got a receptacle in it. Now this isn't the circuit that we would normally wire up, but you might find it when you're troubleshooting this happens accidentally. Let's have a look and see if we can solve some of it. Near the lamp that I'm going to plug into that receptacle, and I'm going to plug that in right now so that we have continuity. So if you see the electrons come out of the negative, they can come down through this branch, they'll go into the lamp, go through this resistor that's in the lamp, and get back down and back to the source. So it completes the circuit by plugging in that lamp. Near the lamp you see a T. This T represents Watt's law. On the top is power, and then the bottom will be amps and volts. So I have two numbers in there, 600 watts divided by 120 volts, and I know that I have 5 amps flowing through that lamp. Next to the receptacle on the right is a T that's going to represent Ohm's law. I can take some of the numbers out of my Watt's law T and put them straight into Ohm's law. So the volts, 120 volts, is going to go into Ohm's law, and the 5 amps can go into Ohm's law. Ohm's law will have equals I times R. So if I'm looking for R, I can divide 120 volts by 5 amps, and that will give me the resistance of 24 ohms for the light bulb in that lamp. I need to look around a little bit more to see if I can figure some things out. Here I have 12 amps at my source. That leaves the negative, goes up and goes around through R1. I have two numbers then at R1, 60 volts and 12 amps, and using Ohm's law I would divide 12 into 60, and then I could calculate that 5 ohms of resistance is at R1. The next thing I can do is, I don't have a total voltage for this circuit. I can use around any closed loop to help me find that out. I see that I have 60 volts at R1, 420 volts at R2, and 120 volts at the receptacle. So around this closed loop I would include those 3 resistances. I will count the voltage around that closed loop. So we have 60 volts, 420 volts, and volts, and that gives me 600 volts as my source. That helps out a little bit. Now I can divide 600 volts by 12 amps using Ohm's law to find total resistance for the circuit, and it works out to be 50 ohms. I also have to finish off this R2. We had 420 volts given to us. We know that it's in series with the lamp, so if the lamp is using 5 amps, R2 is also using 5 amps. Going back to Ohm's law, 420 volts divided by 5 amps, I can figure out that this resistor has 96 ohms of resistance. Next thing I look at is Kirchhoff's current law. I have 12 amps over here at R1. So right in this part of the circuit I have 12 amps. It goes to this junction or node, and some of the electrons keep going and some go down the first branch. We already know that 5 amps goes down that first branch. So 12 amps minus the 5 that go down through R2 and the receptacle leaves me 7 amps at R3. R4 is in series with R3, so it also has 7 amps. To figure out the voltage at R4, I'm going to have to look at another closed loop. I'll look at the larger closed loop here. Again, everything around that perimeter has to add up to 600 volts. I have 60 volts at R1, 420 volts at R3. The missing volts has to show up at R4, and that's just happens to be 120 volts. Now using Ohm's law, I can take 120 volts at R4 and divide it by 7 amps, and I will come up with 17.14 ohms at R4. And we've completed all of the values in that circuit. Now, here's the interesting part. If I were to unplug that lamp, in essence, what is happening is this whole branch in the middle no longer has current flow. If we go over to the right-hand side of the screen, you'll see that I've drawn a new circuit without the R2 resistance and without the receptacle in there, because there is no current flow through that when the lamp is unplugged. Now I'm going to recalculate everything because my amperage will change. My voltage won't change. It's the source. We found out that that was 600 volts. And we found out that R1 had 5 ohms, R3 had 60 ohms, and R4 was 17.14 ohms. We can take those 3 resistances and add them together. Going over to my series circuit rules on the left-hand side of the screen, remember R total equals all of those resistances added up in a series circuit. When I add up 5 ohms, 60 ohms, and 17 ohms, I end up with 82.14 ohms. So for my total supply, I had 600 volts and I had 82.14 ohms. My new amperage then, when I divide that out using Ohm's law, will be 7.3 amps. And you can see that my amperage changed. It actually went down to 7.3 amps from our original of 12 amps. And that's because we lost that one branch. Our resistance actually went up, and you can double check that too. Our resistance went up to 82.14 ohms, and it used to be 50 ohms. Hope you enjoyed that. Thanks.